Hi friends, in this class we will learn the three address code representations. The three address code is an intermediate code used in many compilers. The general form of the three address statement is nothing but A is equivalent to B of C. So here A, B, C are the operands generated by the programmer or and the operator is nothing but a binary operator, any type of operators. To generate a three address code for this one, we take with an example, general example. If I'm going to be consider a is equivalent to x plus y plus z. Now I'm going to be compute this expression. To generate a three address code for this expression, we have to use three different types of operands and one operator and one assignment statement. So now I'm going to be taking a temporary variable t1 is equivalent to x plus y. X and y is going to be computing, and that could be added to the, that should be assigned to the t1. So now the t1 plus z is nothing but t2 I am taking, and this t2 is allocated to the a. So this is the expression a is equivalent to x plus y plus z relevant three address code notation. If you optimize this code, unnecessary memory locations we are going to be removing actually in the line number. So to second line, so t2 is equal to t1 plus z. Instead of t2 equal to t1 plus z, directly we can assign the value t2 to the a values. So if you optimize this code, then the optimized code also we have written here, t1 is equal to x plus y and a equal to t1 plus z. So now we will see the ways of writing a three address statements. So here, so when we are writing a three address statements, so temporary variables whatever we are using, these temporary variables are called compiler generated names. And xyz, in this example xyz are nothing but user defined computational statements related user defined variables. So now consider the ways of representing a three address code. So the general, a three address code can be represented as in the form of a equal to b of c. So another way of representing a three address code is nothing but a is equal to op b also. That is nothing but here the operator is nothing but unary operators. Just example like -5, negation 5, exclamatory mark. So like that, whatever the operators that we are going to be allocating, such type of statement is also considered as a three address statements. And the assignment statement in terms of the assignment statements in the source code is also be treated as a three address code. For example, a equal to b. So simply we can write down the another example for this one is nothing but, for example, if I'm going to be defining that sum equal to 0, this is a general example for this for this assignment statements. Suppose I'm going to be allocating a value sum equal to 0, some term equal to 5, some variable constant, that's also treated as a three address code. And another way of writing a three address statement is unconditional jump statements related to the interleaved execution statements whatever you have written in the three high level language, they are also be treated as a three address code, where L is the label we are going to be representing. So when you're going to be recursively or iterative code whatever you have, that can be written in by using a goto labels. And conditional branch statements is also considered as a three address code. So generally conditional statements is nothing but if followed by some condition, and if that condition is true then go to of L. This entire statement we have to be written as a three address statements. So here expression is nothing but here I'm writing a expression is nothing but a relational operation between b. So here relational operator may be less than, greater than, or anything of the relational operators whatever you have when we are compared with the conditional statements. So not only the interleaved execution, conditional statements and assignment statements. If your high level language, that is combination of procedural calls, so then we can write on the procedural calls related statements also three address code. First we have to be define that all the attributes are the parameters. So here the parameter I am going to be defined as a param a1 a2 a3 and so on n. These are the n number of parameters that are called to the function p. So instead of representing all, so now I'm going to be call the function p, that p contains n number of attributes of a1 a2 a3, and this n number of attributes I'm going to be passing. If it the procedure or the function that returns any value, then use the return related to the data type of a variable or the return data type of that number also. For example, simply I'm going to be representing a simple example, add integer a b c, like that. If I'm going to be representing, then param a, param b, param c, and call add comma three variables. So like that we are going to be call. So whenever the call is occurred, then the call related statements also we are going to be representing a three address notations. or with parameter and without parameters. So like that also here we are going to represent. Here this is the body of the statements I am going to be representing. So like that we are going to be writing a 3 address code for the procedural calls also. If your statements are related to the array of index, array pointer, that is nothing indexed statements. For example, indexed statements are represented with at the rate or at the particular position. For example, a of a is an array. In the eighth array, ith index position, whatever the value that we have. So in that position, I am going to be allocating a value of b. Or if you go to the second notation, an array of a having an index position I, the value is going to be allocated to the variable b. So that is nothing. Index statement is also considered as a 3 address code. So not only the index statements, we have to be read on the pointer statements also. Pointer means either addresses values, we have to be assign the value to a particular variable or allocating a pointer variable or pointer to a value. So such type of statements also be considered as a 3 address statements. So these are the possible cases we are going to be returning a 3 address code. So first one is nothing but a is nothing but B of C. Second one is nothing but unary operators. Third one is an assignment statement. Fourth one is a go to labels or interleaved executions, and fifth one is a conditional statements, sixth one is a procedural calls, seventh one is index positions, and eighth one is a pointer related statements. So these are the possible cases that we are going to be representing. Okay, so let us consider an example. Suppose if I'm going to be generating a 3 address code for this example, x is equal to minus a star b plus a star b. So in this example, when I'm going to be writing the 3 address code, actually the illegal way of writing a 3 address code is nothing but here I'm going to be representing. First if I'm going to be writing t1 is equal to minus a star b. Say 3 address code contains only one operand, two operands, and one operator and one assignment statement. So here if we are going to be assignment statement is allocating a value, and in the computational statements we are using it two different types of operators. This is a illegal way of writing, so that's why I'm going to be representing in the red color. So this way of writing we are not going to be accepted. So now you have to be define the statements. So in this manner, first we have to be allocate the unary operators as per the rule number 2. So you have to allocate a value to the 3 address code representation, that is nothing but temporary variable t1 is nothing but minus a, t2 is nothing but t1 star b, that is nothing but a minus a star b is computed. Next t3 I'm taking as a star b, and next t4 is nothing but t2 is not t2 value plus t3 value. Now I'm going to be allocating this entire value to the x value. So like that we are going to be running a 3 address code. Suppose if I'm going to be constructing a 3 address code for this example. So construct the 3 address code for the high level language that I have written is high level language is. So begin while a greater than b, do begin x is equal to y plus z, a equal to a minus b. So end and x is equal to y minus z and end. So here in this while block, if this condition is true, then this fragment of code is going to be executing. If this condition is false, then out of the while block, out of the while block, then x equal to y minus z I am going to be considering. So here I'm going to be representing that first I'm going to be checking that a greater than b or not. If a greater than b, then go to of 3. So this is the related to the 3 address statement as per the rule number 5. So unconditional go to statements. If a greater than b or a less than b, so relational operator, then go to of l. So here if a greater than b, if a greater than b, then go to of 3. If this condition is fails, go to of 8. In the 8th statement I'm going to be representing that. So x is equal to y minus. After that while block, whatever the statement that I'm going to be executing, that line number I'm going to be representing. This is the line number 8 where I'm going to be calling the line number 8 once this condition is failed. Suppose if this condition is true, then go to of 3. In the third statement I'm going to be computing this x equal to y plus z, a equal to a minus b. First I'm taking a temporary variable t1. The t1 contains a y plus z, and x is allocated to the t1 value. X is having that t1 value, and the next statement temporary variable t2 is nothing but a minus b, and a is having the temporary variable t2. Then go to of 1. So once if this condition is true, if this computation is true, then iteratively we are going to be check that execute the same code until unless a greater than b. So that's why I'm going to be recursively calling go to of 1. Once again go to the statement 1. Once if it is checked that if a greater than b, then the same fragment of code is going to be executed. If this condition is fails, then go to of 8th statement. In the 8th statement I'm going to be representing that x is equal to y minus z. First I'm going to be computing that y minus z, that is nothing but temporary variable t3 is equivalent to y minus z, x is having the value of t3. So like that we are going to be executing. And subsequent whatever the fragment of code that we have, that I'm going to be representing in the 10, 11, 12 statements. So like that we are writing a 3 address code for the given example. If we go to another example, so let us consider another example of writing a 3 address code for this statement. So begin sum equal to 0, term equal to 1, while term is less than 10, do begin sum equal to sum plus term equal to term plus 1. So this is nothing but a 1 to 10 natural numbers summation. So first for this fragment of code, how we are going to be writing a 3 address code. So first I'm going to be allocating a as per the 3 address code rules, as per the third way of assignment statement is also 3 address code. That means that we are going to be assigning a value sum equal to 0, term equal to 1. So like that in our example we have sum equal to 0 and term equal to 1. So these also be considered as a 3 address code. So first I'm taken as a sum equal to 0 and term is allocated to a value of 1, that is also 3 address code. So in the while block for term less than 10, we have to be do the conditions. So when the while block term less than 10, that means that I'm going to be checking that condition. If term less than 10, then go to a 5. If this condition is true, then sum is going to be added for the sum plus term is equivalent to term plus 1. So now I'm going to be compute the inner of the while block. So that inner of while block I'm going to be in the fifth line I'm going to be writing. So now I taking a temporary variable t1. So that t1 is having the value of sum plus term and sum is allocated to the t1 value. For sum I'm going to be allocating the t1 value. So and then term plus 1. So this term plus 1 I am taking as a t2 value, and the term is nothing but having the value of t2, whatever the t2 value that we have, that is allocated to the term. So once this is a while block statement. To recursively execute this while block, once if this statement is executed, once again go to the third statement. That means that recursively check that until unless term is less than 10. So then we are going to be repeat that loop. So after that while block we don't have any other statements, so that's why we are going to be terminating this. This is the last statement. 10th statement is the last statement. So that 10th statement, once the condition is failed, then we are going to the go to of 10th. So that 10th statement we are going to be moving on subsequent out of that control from the while block. So in this manner we are going to be writing a 3 address code for the given example. So in the next video we will go through the different examples on the 3 address code. Thanks for watching.